The main parts of DC generator are yoke, poles, pole coils, armature core, armature winding, commutator, brushes and bearings. The yoke serves two purposes. The first purpose is it provides mechanical support for the poles and it acts like a protecting cover for the whole machine. The second purpose is it's going to carry the magnetic flux produced by the magnetic poles, and in case of small generators where we are mainly concentrate on the cost rather than the weight of the machine, we are going to construct the yoke by use of cast iron material. But in case of large machines where the weight is more important rather than the cost, we are going to use cast steel or rolled steel for the construction of yoke. And the modern process of making the yoke is we are going to roll the steel slab in a round shape by using a cylindrical mandrel, and then the edges are going to be welded at the bottom side. Once the cylindrical shape is formed, after that we are going to attach the feet and terminal boxes to the yoke at the bottom side. Such yokes possess sufficient mechanical strength and they will have high permeability. The field magnets of a DC machine are going to consist of pole cores and pole shoes. The pole shoes serves two purposes. The first one is they are going to spread out the flux in the air gap, and the second purpose is they are going to support the exciting coils or field coils. And mainly there are two types of pole constructions. The first type is the pole core is made up of as a solid piece, and this solid piece is made up of cast iron or cast steel, and the pole shoe is laminated. The second type is the complete pole core and pole shoe are built up of thin laminations of annealed steel, and they are going to be riveted together by using hydraulic pressure. And the thickness of laminations varies from 1 mm to 0.25 mm, and the laminated poles may be secured to the yoke in any of the following two ways. The two ways how we are going to join the poles to the yoke is either the pole is secured to the yoke by means of screws bolted through the yokes, or the holding screws are bolted into the steel bar which is passed through the pole core across the plane of laminations. The field coils or field windings are going to consist of copper wire or copper strips, and they are going to be formally wound in the correct dimensions. Afterwards, once the wire is formed, the former which is used to form the winding is going to be removed from the wound coil, and the wound coil is put into the place over the core. And when the current is passing through the field coils, they are going to be electromagnetized. They are going to electromagnetize the poles and they will produce the necessary flux. Armature core houses the armature conductors or coils, and it makes the conductors to rotate in the magnetic field produced by the field poles. And the most important function of the armature core is going to provide a magnetic flux path of low reluctance for the flux produced by the magnetic poles. And this armature core is made up of cylindrical shape, and it is usually in circular sheet steel discs or laminations having approximately 0.5 mm thickness. Up to 1 meter diameter, the armature core laminated core is going to be made in a single cylindrical shape with circular shape laminated piece. But whenever the diameter is going to exceed the 1 meter, the mechanical strength of the diameter, that is laminated piece, is going to decrease due to the small thickness of 0.5 mm. So to get better mechanical strength, that laminated core is going to be made into several number of segments, and all these segments are going to be joined together to form the circular shape. Usually the single circular segment can be made into 4 to 6 segments to get a single core where the diameter is going to exceed 1 meter. Sometimes even 8 segments can also be used. And the purpose of using laminated is to reduce the eddy current losses. Whenever the thickness of the laminations is going to decrease, the resistance offered by the induced EMF, the resistance offered to the induced EMF is going to be very small, and the current, and hence lesser the I square R losses in the core. The armature windings are also of usually farmer wound type. First, we are going to form the winding in the form of flat rectangular coils and then pulled into the proper shape in a coil puller. Various conductors of the coils are insulated from each other, and the conductors are placed in the armature slots which are lined with tough insulating material. The slot insulation is folded over above the armature conductors placed in the slots and is secured in place by special hard wooden fiber wedges. The main function of the commutator is to facilitate the function of collection of current from the conductors, and generally the commutator is going to convert, or it's going to rectify the alternating current EMF that going to be induced in the armature conductors into DC that going to be flow through the load. It is of cylindrical structure and it is built up of wedge-shaped segments of high conductivity hot drawn or drop forged copper, and these segments are going to be insulated from each other by thin layers of mica. The number of segments is equal to the number of armature coils. The function of brushes is to collect the current from the commutator segments, and these are made up of carbon or graphite material which are going to result in less amount of voltage drop, and these brushes are going to be housed in a rectangular shaped brush holders, and the brushes are made to come in contact with moving commutator segments by using a spring tension, and this spring tension can be adjustable by using a handle that is going to be mounted on the brush holder box. Next, a flexible copper flick tail is going to be mounted on the top of the brush, and it conveys current from the brushes to the holder. The bearings are going to be mounted over the shaft for the smooth running of the machine, that is armature. The ball bearings are frequently employed due to their reliability, whereas for heavy duties, roller bearings are going to be preferable. And the ball and rollers are generally packed in hot oil for quieter operation. So, as the bearings are packed in a hot oil, the noise that is going to be produced during the operation is going to be reduced. And for reduced bearing wear, sleeve bearings are used.